Hi, this is the Max. So I'm doing a Trig function that I'm going to differentiate. It's a little bit complex. So what you need to understand over here is that essentially you have the product of two functions. That is 2x is a function on its own, and all of this tangent is a function on its own. So I'm just going to rewrite it. It's 2x then tan of 3x minus pi over 3, and then we can go ahead and put the 4 over there. Now, what I was now alluding to is that this is a function on its own, and also this all over here is a function on its own. So that implies that we have to consider quite a number of things. One of them, to solve this, two of them, we were using the product rule. But when you look at the yellow one, when you look at this one over here, this one will imply us to use the chain rule. So I think that will be our first takeaway from there, where the chain rule, we remember, is dy dx is equal to dy over d something, I will use du, times that d something over dx. So this is what we're going to use for that trig one, the trig function in there. Okay, and I'll do it, and eventually when I'm done with finding the derivative of the trig function, then essentially I am going to then use the product rule. So I'm just going to create sort of a barrier here so that I can do it, a little bit on the side. So writing down what we have, I'm saving as I'm going because sometimes, software lets me down. That's why you need to donate, find ways to get in contact with me so that we can make this project bigger. I need to upgrade quite on a number of things. Now, let's do the tangent function that you have there. So let's say, number one, let's say u is equal to the tangent of 3x minus pi over 3. Okay? And before I do the second one, maybe I can do du dx. And I'm going to do du dx. Du dx, the derivative of tangent is sec squared of the same stuff. And you're going to multiply that with the derivative of what is inside. Okay? So cleaning this up gives me 3 sec squared 3x minus pi upon 3. So this is du dx. The second thing that I'm going to say, I'm going to say let y equals to u to the power of 4. Okay, remember I'm still busy with that yellow, that one there. Now, if you were to do the derivative of this is just dy du using the power and reducing by 1. Since I know what my value of u is, I think I can just, for the sake of progress, I can just go ahead and replace that u with that. But I'm still going to leave this one as dy du. So I'm still going to say dy du, which is now 4. Now what was our u again? It's tan 3x minus pi over 3. Okay, not actually any need for those brackets. So let me just clean it up. So I say it's 4 tangent of 3x minus pi over 3. So what do we have? Well, we have a number of things here that we can consider. We have du, dy du, okay, which is from our chain rule gonna be there. We also have du dx, which is all the stuff that is over here. So by virtue of the chain rule, that detects that we need to multiply them together. Okay, so I'm going to do that over here. So by the chain rule, I have dy dx is going to be, again, I have to save because this is quite stressful. If I have to take this and it should be multiplied with, let's go grab the yellow one. It should be multiplied with this one over here. Okay, right, so I can actually clean it up. So remember, I'm still busy with the trig function. Okay, so at the end of the day, this one gives me 12. Okay, just want to see if I did not leave out something. You see here, when I was now substituting my u back, that 3 is over there, so we're going to put it back over here. Okay, from here. Always refer back to your work so you can see if there are no errors. Essentially the same, we're going to put it back there. Okay, so 4 times 3 is 12. 10 to the third power of 3x minus pi upon 3, sec square of 3x minus pi upon 3. So I'm done with the trig function as it is. Okay, so let's just go and grab our original function. So now I'll be ready to apply the product rule. Okay, so applying the product rule. So what does the product rule say? The product rule says if you have to do dy dx, you keep the first, so 2x remains, multiplied by the derivative of this second, and the derivative of the second is all of this. I'm just going to grab it so I do not make a mistake. That's what it says. Okay, make sure you follow the product rule. Say take the first times the derivative of second plus keep the second, which is 10 to the 4 of 3x minus pi over 3, and then you multiply that by the derivative of the first. Derivative of 2x is nothing but 2. I think we are close to being done. Okay, let's multiply this side. You're going to have 2 times 12 is 24x. You have 10 to the third of 3x minus pi over 3 sec square 3x minus pi over 3 plus, then just put the 2 in front, 10 to the 4th of 3x minus pi over 3. Beautiful. And ladies and gentlemen, that there is the derivative of that function. Okay, just highlight it properly and nicely. It's complex. It's quite a few things that you have to do, and that's why I prefer that you space your work in such a way that you can separate them. Don't try to do everything at the same place. Be very careful for leaving out certain things, and then always go back and check to see if you are on the right path or you didn't leave out something. But to do this, you have seen that we have used the product rule, we have used the chain rule. You need to know how to find the derivative of trig functions. So there's quite a lot in that question. It's loaded. It's a very interesting question.